Now let's go back to the book Contagion Myth, which I asked you. I said, what was the purpose of writing this book? You said, you kind of need to know my background to know why I wrote this book. Now that we know your background, what was your inspiration to want to write that book?
Basically, because I looked through the history of contagion, and if you would permit me, I'd love to share what I found out with your listeners.
Please.
So what are we talking about here? We're talking about that the normal observation that a certain person gets sick in a certain way, let's say a cold or a flu and then somebody else in their vicinity or their family or whatever gets sick in the same way. And one says something was passed between the first person and another person. And this is a very normal, clear observation. We've all had it. And in fact, interestingly, it was first described at least 2,000 years ago by the ancient Greeks. They said there's something that's passed between people. We don't know what it is. They thought the spirits or who knows what. They couldn't see anything. And then they thought there must be something contagious. And we go then for about 1,800 years without being able to find the agent. Now, I would point out that this sort of Western science, Western medicine, is not the only stream of thought going on in those 2,000 years, right? There's Chinese medicine, there's probably traditional Iranian medicine, there's Native American medicine, there's Ayurvedic medicine. These are very old, successful medical systems. And what you find is none of them thought diseases were contagious. None of them. There is no concept in Chinese medicine that something unseen passes from one person to another. And in no other system did that exist. Now, of course, that doesn't mean it's true. They could have all been wrong. But when I looked into it, I thought that was sort of interesting. So then we get to around the 1800s, and now we're really talking about 1850. And there was what I call the first eureka moment, right? So we're thinking one person is sick, another person gets sick, there must be something spread. And that observation is what's called epidemiological observation. Now, I just want to point out something here, that this contagion theory was applied to the following disease. There was a bunch of sailors who got sick, and one sailor after another got sick, and their teeth fell out, and then they went into heart failure and died. And this happened in the thousands and thousands of people. And it was usually one ship after another. And for 100 years, they said this must be contagious. And then somebody ate a lime and the whole thing went away because it turns out it was scurvy. And the reason I point that out is epidemiological observations, like this person got sick and then somebody else got sick, is well accepted in medicine. That is not how we prove causation. And you hear this now all the time. Well, a lot of people in one place got sick, so it must be a virus. Well, they blew a bomb off in Hiroshima. A lot of people got sick and nobody thinks that was a virus. Or they'll say, if it spreads from one place to another, that proves it's a virus. So I'm sure you remember Chernobyl. There was a nuclear accident. A lot of people died. It started spreading into Eastern Europe and then Western Europe. A lot of people got sick. And as far as I can tell, that's no evidence that that was a virus. In other words, the idea that a lot of people in Iran or Turkey or Spain or the nursing home or the cruise ship or the whatever got sick, my Aunt Bessie went to a party. Those are epidemiological observations, the purpose of which is to generate theories which can be tested for causation, period. And I would agree 100% that we had enough evidence with contagion that we should investigate for an infectious cause or an unseen agent. Now, that's what Louis Pasteur famously did. He said, there's all these people, and in fact, what he used was the case of sheep and said, there's all these sheep getting sick, one sheep after another. Sometimes the people who were handling the sheep got sick. So there must be something that's passed. they then had invented the microscope. So the first eureka moment in history then is they could see this bacteria under the microscope. And they saw the bacteria in the sheep, and they saw it in the next sheep who got sick. End of story. That's what caused the sheep to get sick, called anthrax. But here's what happened then. Pasteur isolated the anthrax bacteria from the sheep, right? So he took them out, and he gave them to other sheep, and none of them got sick. None of the people got sick. Now, here's the way I think people should understand this. Imagine you have a cow, and you don't feed the cow proper food, which is grass, right? You feed it cardboard and dead cow parts, and and you soak it in glyphosate and tick poisons, etc. All that stuff comes out in the milk. Now, then somebody drinks the milk and gets sick. That's contagion, right? And then you look in the milk and you see a bacteria called listeria. And you say, okay, that may be the causative agent. And then you look in the stool of the person and they also have listeria. End of story. And so the listeria, you drank listeria, it made you sick. Now, unfortunately though, or maybe fortunately, there's another explanation for that, which is the cow was sick, the milk, the poisons went into the milk. The role of bacteria in nature is to biodegrade poisons, right? If you have a compost pile and you put dead squirrels in it, you'll get bacteria to eat the squirrels. If you have a pond and you put poisons in it, you get algae growth that eat the poisons. If you have a forest and you cut the trees down, the algae and the fungus and the bacteria eat the dead trees. That's called biology. That's called bioremediation. So how do you know that the listeria isn't there to digest the poisons in the milk? So we have two very clear explanations for what may have happened, right? It's either the bacteria or it's the poison, and the bacteria are not causing anything. They're just helping you out by eating the poisons, as they do in nature. Now, what I tell people is this is what Pasteur and his colleagues did for 40 years, because there is a very simple way to sort this out. All you have to do is isolate the listeria from the milk, right? You can't give them all the milk because then you don't know if the poison's in it. Isolate the listeria, give that to a bunch of animals, see what happens. That's what they did for 40 years. And as far as I can tell from the medical literature, no animal or person gets sick.
Now,
so it must be the milk.
Yeah. So when I was looking at the difference between him and Dr. John Snow, and I'm sure you studied Dr. John Snow as well, where he had a different angle that he had. What was the difference between the two of them, between Dr. John Snow and Pasteur?
Yeah, I don't know who John Snow is. You mean Beauchamp?
Not Beauchamp. Dr. John Snow is also during the same time as 1850s, because I know Pasteur died 1895. During the same time, Snow was linking everything to water. So I know you're specifically isolating water, milk right now because of pasteurization. And, most of us just say pasteurization and we don't even know where it comes from. Some of us know it comes from the name Pasteur, but he was also talking about how a lot of the viruses were coming from water rather than somebody's breathing and coughing on you. That's how I got sick. It was the water.
No, I don't know this Snow, but the two main people then were Pasteur and Beauchamp. Beauchamp said it's not the bacteria and it's the terrain. Now, so essentially Pasteur and his colleagues tried for 40 years. And in fact, it's very interesting what happened then, because a German colleague named Robert Koch came up with very simple guidelines so that we would know whether a microorganism is causing a disease. And it's very simple and straightforward. They're called Koch's postulates, and they are the hallmark ever since of how we prove causation. And it's very simple. You take like 100 sheep or 100 people with the same disease, and you identify an organism that's the same in all of those 100 people, right? Here's a way to think about this. I came up with this last night. If you had a disease called swollen thumb syndrome, and so 100 people with swollen thumb, and you ask them, what happened to you? And they said, I don't know, somebody came along and bashed my thumb with a hammer, all 100 of them. Mm-hmm. So that turns out not proof. So you go to the next 100 people who don't have a swollen thumb, and you say, did any of you get bashed with a hammer? No, none of us. So that's postulate number 2. No people who are healthy have that organism, right? Because if they have it, then why didn't it make them sick? That's still not proof. Then he said, you have to take the organism from the sick people, isolate it, purify it, give it to the unhealthy people, and if they get sick, you prove causation. In other words, you take the hammer, bash 100 healthy people, and if they all get a swollen thumb, that's how human beings understand causation. Every human being would say, yes, I'm sure that the hammer is what causes that. And here's the trouble. Koch eventually said, these postulates don't work because there's not one case in the medical literature where they've proven the postulates. Not one. We've looked for 20 years. They say they do. They say they're still valid because they're common sense. I have reports even from this current episode. You know, we see epidemiology, somebody should do Koch's postulates. And then we have a report from this current situation, Koch's postulates were fulfilled. But the trouble is they never isolated an organism. They never made an animal sick. And they didn't do Koch's postulates. So that's how this got started. Okay, go ahead.
Go ahead.
So the next step, so they failed to prove causation with any bacteria. Then they say, well, we have diseases now which we can't find a bacteria, right? But we know that must be an infection because it looks like it's contagious. So there must be something smaller than a bacteria. And the main disease was polio. So they looked in the dead brains and the spine. They looked for a bacteria. They couldn't find it. And so they said, there must be something smaller that's poisoning these children and these people. And they called it a virus. They didn't see a virus. They didn't know what they were looking for. They just said, there must be an infectious agent. And so then they said, okay, we're going to try to isolate this because they were still interested in these Koch's postulates. And so they put it through a filter. So they had filters that could filter out the bacteria in the cells. So they took children or people who had died of polio, they ground their brains up, put it through a filter, and then they took many, many different animals and they fed them this filtrate, and none of them got sick. None of them. And then they injected it subcutaneously into monkeys, hamsters, guinea pigs, you name it. None of them got sick. And then they said something very interesting, which is, it turns out there's no animal model for polio, which is a bizarre way to think. Because what they're saying is, we cannot make an animal sick with this virus filtrate that we can't see. And then in 1907, they did the experiment that proved that polio was contagious. They took a child who had paralysis, they took a piece of their spine, they ground it up in a blender, they filtered it, and they took 2 monkeys, I think they were rhesus monkeys, drilled holes in their brains, injected about 1/2 cup of this stuff into their brains. One of the monkeys died. One of the monkeys got paralyzed. They didn't do a control. In other words, they didn't just inject 1/2 cup of, water or something. So they don't know if the monkeys died because monkeys don't like having 1/2 cup of stuff injected right in their brain. Maybe they had a herniation. And they held the monkey up and they said, see, we proved polio is a transmissible disease. Now, I don't know about you, but I can see you frowning there. That doesn't sound like science to me.
So this entire study was based on 2 monkeys?
2 monkeys. The idea that polio was caused by a filterable thing we couldn't see, right? That's the studies. Now, so we go on from there. Then we go to 1918. So now they say, we've proven that there's something filterable, right? You know, we got rid of the bacteria, we got rid of the cells. It could be a poison in there, could be arsenic, because it turns out that lead arsenic and DDT later caused the same symptoms as polio. And so they didn't know that, or maybe they did, but they ignored it. So they could even have had arsenic in the water. But anyways, because they didn't do a control, they have no idea, they can't find that out. So then they go to 1918, and about, 20 million people die from this Spanish flu. Highly contagious disease, right? And then, they see one person after another. And again, epidemiology is not how science proves causation. They only tell you, you should look here. So they did. The Boston Health Department did a study. It's referenced in the book. I can read you the conclusion if you want. They took about 100 people who had active symptoms of the Spanish flu, right? This is killing millions of people. They're snotty nose, coughing, everything. They got 100 volunteers, and they divided them into 3 groups. One group, they spent 10 minutes breathing as hard as they could into their mouth, like that, right into their open mouth, 10 minutes.
Yep.
The other group, they spent 10 to 15 minutes coughing right in their face. And the other group, they actually took mucus out of their nose, right? Sucked the snot out of their nose and injected the snot right into the volunteer's nose. These are 100 people. The Boston Health Department does this. And you know how many of these volunteers got sick? 1. He got a runny nose, which I have the quote here. I could read it to you if you want. That says, it turns out that none of these ways are able to pass the transmissible agent from one person to another. Now, you can look at that and you could say that then they came to an interesting conclusion, Patrick. They said, it turns out we needed to be more aggressive in exposing the volunteers. And I thought to myself when I read that, like what, do a lung transplant or something? I mean, how can you be more aggressive than that? They sucked the snot out and injected it, and literally one person who they said this is not the flu, they just got a runny nose because we injected some snot up their nose.
I mean, that's pretty intense. I just want to ask something, if you can hold that thought, because so 100 people were tested. This is the Spanish flu era.
1919.
1919, a third were asked to breathe 10 minutes open mouth into somebody else's face.
Open mouth. Open
mouth, strong into
like
their face.
Kissing, like kissing.
And then the other one was 10 or 15 minutes coughing into the face. And the last one was taking mucus out and injected it into the other person. And only 1 out of 100 got sick, and they had a runny nose, not even sick.
Right.
So now here's my question for you. So then, based on what you're saying is we cannot give our germ to somebody else. That's what you're saying. That's not possible. I can't give my germ to somebody else. Is that kind of what you're saying?
No, that is not what I'm saying, because that doesn't prove you can't give germs. What it proves is you can't give sickness to somebody else.
Okay, then let me question you on that. If you can't get sickness.
There's a big difference there, Patrick, right?
Perfect. That's good to know. But I again, as a parent, this is a epiphany moment I'd love to have. So I have 3 kids. You know the saying. Once one kid gets sick, everybody gets sick, right? Or, a parent gets sick when they have a baby and they have a 2-year-old kid in their house. And then they get sick. Oh my gosh, I'm sick. Now my other son is sick. Now the mom is sick. And then at night when the mom sleeps with the dad, then the dad is sick, and that kind of goes. So that kind of, that argument kind of doesn't validate what happens in a lot of families, because when kids are around other kids, they tend to get sick. What would you say to that?
I would say the same thing I would say with every epidemiological observation, right? You're talking epidemiology there. One person gets sick and then another person gets sick. The same thing that happened with scurvy, the same thing that happened with Spanish flu, the same thing that happened with anthrax, the same thing that's happened with polio. Now, you have to take that observation and prove causation of a microbe. They did that over and over again, and they cannot prove Koch's postulates. They cannot prove causation. And all I would say, now, in the book, we do propose very specific reasons why those observations might happen, right? So I can explain exactly how you can understand that event.
I'd love to hear it. Go for it. I'm all in.
But I think that comes later.
Okay.
Because we still have to, you have to stick with the argument, which is you have to take that observation, right? And then isolate a virus or a bacteria and prove that it can cause that disease. They've tried that for 150 years and they can't prove it. In fact, they can't demonstrate it. So, we don't know if there's some sort of similar toxic exposure in your house, whether there's some sort of resonance phenomena, like if you put 10 young women in a cabin for 6 months, they all start menstruating at the same time. There's no virus there. So you can see physiological responses happen for lots of reasons. And in order to show that it's a microbe, you have to go through the steps. And they try over and over again. And I can keep going if you want and see how they try. And it turns out it's not the microbe. I also understand, Patrick, how bizarre this may seem to people, because they get stuck on the epidemiology. They get stuck on this observation. This observation has been around for thousands of years. Same with scurvy, same with lots of things. It turns out we have a scientific method to prove it. We looked, and it turns out that's not the cause.
So what is?
Well, I just said, basically, these phenomena are elimination of toxins. So the trouble is we're skipping ahead here. And I would rather go back and see how the virus theory actually came about.
Here's what I'd like to challenge you to do. My challenge to you would be, try to explain it to a 6-year-old to understand, who's not in your world and doesn't fully understand all the technical terms. Speak to me as if the average person is listening to this saying, you know what, doc, I really want to learn, but I don't understand how this is even possible if, based on what I've experienced and what I've been told my entire life with visiting doctors, this is what I've seen. So if you can explain that and pack it into a fairly short amount of time to the best of your abilities, I'd love to hear that perspective from you.
So here's some facts about what we're calling a cold or a sickness, right? So essentially what happens is you're well, and then you usually get a fever or some other symptom. And then after that, what happens is you get a runny nose or mucus or cough or some sort of snot happens. And then what happens is you're better. And in fact, when we do the studies of what happens, for instance, with a child with chickenpox, right? So child with chickenpox, once they go through those stages, it turns out they're better for life, meaning they have less asthma, they have less eczema, they have less cancer, they have less osteoarthritis, they have less heart disease. All these are clearly in the medical literature. Now, here's another one, and I wrote a whole book on the cancer about this. It turns out that the most reliable way to treat cancer, and this was done with Coley's toxins, and it was done in the 1920s, is if somebody has cancer and they get a fever because they supposedly have an infection, then they have a much better outcome, and some of them are even cured of the cancer. In other words, this process that you're calling getting sick is simply a detoxification reaction. So in other words, you poison somebody with whatever. It could be emotional poison, it could be bad food, it could be toxins in the house, it could be that we're all exposed to glyphosate, it could be that we're all exposed to electromagnetic fields. All of these things distort the gels in our cells, and then the body has to flush them out. It does this through making fever, making mucus. We call that infectious disease, and it turns out it's just a detoxification reaction. And the thing about it is when you treat it like that, you get people who have no bad outcomes and are better for life. That's what's happening. Now, there's something even very interesting about this, because we now know from very clear scientific studies that if you poison a cell or a tissue, it breaks down into little packages of genetic material, which are called exosomes, as a method of detoxification. In other words, it's similar to how a tree does. If you have a beetles eating a tree, they send out signals to tell all the other trees that there's been something happening that's noxious in their area. And then the other trees make a defensive response. Now, I'm aware that this may be more than a 6-year-old can do, but I'm trying my best to be as clear as I can here. So what's happening then is one child starts the process, and then they send out this signal to the other children, and even maybe the parents: you should make a defensive detoxification reaction. Unfortunately, we misinterpret that as sickness. We even misinterpret that the body makes these detoxification packages that are called exosomes, which are mistaken for viruses, and they're not contagious, they're not infectious, they're how the body communicates what's happened and detoxifies.
So can I ask you simple questions, okay?
Sure.
And simple answers. Let's see if we can pull this off. So, Doc, how do I get sick? Do I get sick through respiratory? Do I get sick through water I drink? Do I get sick through the food I eat? Do I get sick through the way I think? How does one get sick?
There's basically 4 mechanisms of getting sick. 1, injuries, right? You fall off a cliff and break your leg, that's a kind of sickness. Number 2, starvation. That's like scurvy, that's like beriberi, that's like pellagra. You don't have the nutrients, you don't have enough collagen, you don't have enough vitamin C, so that the tissues start to break down and they excrete these poisons to essentially try to detoxify. So number 1, injury. Number 2, starvation. And then 3, which is the biggest, is you're poisoned. So in other words, just like the milk example, you poison the milk, the bacteria come and eat the poison. And it's the same argument as if you think because the bacteria are there, they're the cause of the problem. That's like saying you go to a town and you see fires, and then you see firemen there, and so the firemen must be causing the fires. Actually, the firemen are there to clean up the fires and put out the fires out. The bacteria are there to biodegrade dead and dying tissue. So why is it dead and dying? Because it's been poisoned. With what? I mean, you want me to, each of us have 120 carcinogenic chemicals in our blood and urine, and all mother's milk does. We're exposed to electromagnetic fields, which we have 1,200 studies that show that they do harm. Glyphosate is in the air pollution, cyanide. There's lots of ways people are poisoned. And the final one is we have emotional toxicity or poisoning. or I sometimes say the way we think. Because if you think in this way that the world is out to get you, that instead of this, the world is a cooperative venture, that's really the model that I'm trying to bring here. The world is a cooperative venture. It's not this survival of the fittest model that was just a construct. Once you see it like that, that's the terrain theory. That's I have a healthy terrain and I'm resistant to sickness.
So 4 ways we get sick: injuries, starvation, which is scurvy, bury. This is when you're not getting enough nutrients, collagen. 3 is poison, similar to the story of the milk. And 4th one is emotional toxicity. The world is not out there to get you. It's a collaborative effort. And if you look at the world in a different way, you won't get sick. So if I were to ask you, when's the last time you got sick?
Patrick, let me just interrupt for a minute. Because when you look at if you permit me, when you look at how we prove viruses are contagious or are pathogenic, that's not contagious. Let me change that word. So how does a modern virologist prove a virus is contagious? Let me go through the steps. So you take somebody who's sick, like your child with chickenpox, right? And you take some of the mucus from that child, and then you centrifuge it, which is not purification, right? So you have all kinds of cells and stuff in there, and you don't have a pure virus. And then you take that tissue and you take that stuff, right, the mucus, and you inoculate that on a tissue, like a monkey kidney cell, or a fetal skin cell, or an immortalized lung cancer cell, right? You take that unpurified stuff and you inoculate it on a tissue and see whether it grows and kills the tissue. You with me?
Sure.
Now it doesn't. And that was the problem of virology. So they figured out that they had to starve the tissue and poison it with antibiotics and oxidizing agents, and only then would the so-called virus kill the tissue. And that's how they prove that the viruses kill the tissue. And then they get this material from the breakdown of the tissue, and they say, see, the virus killed the tissue. And the reason I say that is because it's the exact same model as how we get sick. They starve and poison the tissue, just like we're starved and poisoned, and then we break down and create these particles, which are unfortunately called contagious viruses.
So what was your point of going where you just went right now when I was explaining the 4 reasons why you stated to me why people get sick? Why did you go there? I'm curious.
I went there because there's this interesting correlation between how virologists prove viral causation and the exact correlation with my theory, my proposal, with how human beings and animals get sick. Starvation and poison. That's how they make viruses kill cells.
So when's the last time you got sick?
I don't remember.
You don't remember?
I don't remember.
Like it's been decades?
Well, not decades, years.
Okay, so you don't get sick?
I got sick every once in a while.
Interesting. And when you do get sick, are you the kind that's curious to find out how you got sick, or very rarely do you find out why you got sick?
It's very difficult in any one particular person to find out what the starvation or poisoning or inciting event was. Now, but that's what I spent my career trying to find out what happened to people.
אם אהבתם את הסרטון הזה, אתם מוזמנים להצטרף אלינו באתר nowhere, מקום לדעת, בו אנו משתפים איתכם את הסרטונים שיוטיוב, פייסבוק וטוויטר מנסים לצנזר. הצטרפו אלינו בטלגרם ותמכו בנו בפטריון, כדי שנוכל להמשיך ולחזק את הערוץ ולשתף את האמת על הבריאות והעתיד של כולנו.